Modern AI tools like Claude demand standard HTTP protocols, but legacy enterprise SAP routers actively block them. This is a fundamental operational failure. You might have an AI that can completely rewrite your ABAP architecture, but it literally can't get through the front door. Today, we are looking at the absolute friction between cutting-edge model context protocols and rigid legacy firewalls, and more importantly, how to force a connection anyway.
Here is the core architectural conflict. Claude connects to systems using the Model Context Protocol. It expects to use HTTP REST over standard ports. But the enterprise firewall dictates completely different terms. It restricts traffic exclusively to native DIG or RFC protocols. It denies raw routing to the HTTP port entirely. You simply cannot put a router string into an HTTP proxy. The client has absolutely no idea what to do with it. As a result, modern development velocity crashes straight into a legacy brick wall. The connection just dies.
But this is where we find a fascinating systemic contradiction. I call it the Eclipse anomaly. Eclipse ABAP development tools connect perfectly to these exact same locked-down systems. Think about it. The firewall rules haven't changed. The SAP router is still active. Raw HTTP is still blocked. Yet, Eclipse bypasses the blockade entirely. It works flawlessly. If Eclipse can connect without plain HTTP, it means we can too. We just need to reverse engineer the mechanism.
To figure this out, we ran a network capture to intercept the traffic. Look at a raw HTTP request. The router evaluates it and immediately slams the door shut. Route permission denied. But when Eclipse ADT traffic hits that exact same router, gateway and RFC routes are magically permitted. The traffic flows right through. This network postmortem proves something absolutely critical. Eclipse abandons plain HTTP entirely. Instead, it wraps its payload in a completely different protocol. It uses RFC serialization.
The architectural skeleton key to all of this lies in a single standard SAP function module, SADT REST RFC endpoint. Here is exactly what happens. Eclipse takes a standard REST API call, it packages it inside a length prefixed RFC payload. Then, it tunnels that HTTP request directly over the SAP native network interface. Once the function module receives it, it unpacks the request. It runs it against the ADT framework internally, and finally, it returns the response packed right back inside an RFC. This brilliantly bypasses the HTTP port entirely, and it uses the exact same authorizations your user already has.
So, the tunnel exists, but forcing a stateless protocol to behave like a web server, that creates severe structural friction. For one, RFC lacks HTTP sessions entirely. Plus, the endpoint explicitly rejects HTTP head requests. It throws a 400 error right out of the gate. And finally, ADT clients absolutely demand CSRF tokens to execute write operations. Because there is no HTTP session, no token is issued. The client just refuses the write. The connection is technically open, but the protocol itself is completely broken.
To resolve this, we need a local middleware to act as a translator. Enter the local Python bridge, sitting directly between Claude server and the SAP system. This tool leverages the PyRFC library to natively accept SAP router connection strings. It traverses the router exactly like Eclipse does. It maps your localhost HTTP requests directly to SAP native RFC calls. We just expose a local port to Claude. We let Python do the heavy translation, and the legacy firewall remains entirely untouched.
To survive that protocol friction we just talked about, this bridge executes some critical payload manipulations. First, it intercepts those problematic HTTP head requests. It converts them to GET requests before they ever hit the function module. Next, it drops the resulting GET response body. This perfectly simulates a valid head response for the client. Finally, it synthesizes a placeholder XCSRF token. The function module is already authenticated by the RFC logon, so it doesn't actually validate CSRF. The client is satisfied, it believes it has a valid HTTP session. The illusion is complete.
What makes this operational scope truly incredible is the backward compatibility. This isn't just some modern S/4HANA trick. This mechanism functions natively on classic ECC and R3 landscapes. The only hard requirement is this. The system must possess the ADT backend. If it runs SAP NetWeaver 7.31 or higher, it works. The rule of thumb is simple. If Eclipse can open the system, this bridge can drive it. You can literally bring cutting-edge Claude AI to your oldest, longest-running landscapes. Implementing this requires passing through 4 main system gates. Start by installing the 64-bit SAP NetWeaver RFC SDK. Crucially, you must match your system architecture precisely. You need a 64-bit Python installation and a 64-bit PyRFC library, even on ARM Windows. Architecture mismatch is the #1 setup pitfall here. After configuring your bridge credentials in the environment file, simply point your MCP server to the localhost port. The bridge connects lazily. Idle clients will never unnecessarily log on to your SAP system.
Before you set this up, there is one primary operational hazard you must be aware of: account lockout safety. Every ADT call over this bridge represents a distinct RFC logon attempt. If your bridge authentications fail, they translate directly to RFC logon failures. If you script automated retries, SAP will lock your user account immediately. The bridge itself will not auto-retry a failed logon. You must use strict manual intervention. If an error occurs, stop, fix the credentials. Do not loop.
We've seen the architectural blueprint, we've seen the bypass, but it brings us to an ultimate operational conflict. Does enterprise security truly protect legacy systems, or does it simply isolate them from the AI revolution? We are actively building complex bridges just to drag modern intelligence through legacy firewalls. Are these blockades genuinely serving security, or are they just killing development velocity? I want to know where you stand on this. Let's debate it in the comments below.